Hi guys, welcome to our lesson on the female reproductive cycle. We will be emphasizing the endocrinology as we go through it. As I told you in the overview lesson, this is a double length lesson. That is, it is twice as long as a normal lesson, and that's because the female reproductive cycle is reasonably complicated. So we're actually going to go through this cycle twice. Once through, we're going to do an overview, and then once through, we're going to emphasize gametogenesis, development of the oocyte and folliculogenesis, we're going to emphasize development of a follicle around that gamete, and then we're going to talk about the menstrual cycle in terms of the hormones that are released and the cyclic nature of that part of the cycle. And if you include the histology lesson, we'll be going through this cycle at least 3 times. And the reason is because it's reasonably complicated. It's very hard to correlate changes in all these things all at once and pinpoint exactly what changes are taking place when. And so the best way to do this is to go through it over and over and again, emphasizing different things each time you go through it, and referring back to the last time you went through it as you do it the next time. We've found that this works best, at least I've found that this works best. I know many of you hate repetition, and you want these lessons to be efficient. I think this is the best way to do it while maintaining at least some degree of efficiency. I'm sure some of you will be frustrated by it, but I think many of you will be glad to have gone through this cycle a couple more times because it is reasonably important. It is the heart, really, of this block, at least in terms of the physiology, the anatomy, and the histology. And you really do need to sort of nail it down. So one of the things that you will note about the menstrual cycle is that it is circular. And that means that you can start anywhere in the process, and assuming pregnancy does not take place, you will go around and go through the cycle, and you will come back to the place where you started at. And that will happen every single time until you stop cycling. We will choose to start at the phase just after menses when we go through it here, but you could start anywhere literally, and you just come back to right where you started with. So you could teach this a number of different ways. It's just the way that we choose to do it. But there is no start of the cycle and end of the cycle in the literal sense, though we may refer to it that way. It is cyclical on a couple of different levels, which is why we're going to go through this cycle at least twice. The development of the ovaries and the changes to the follicles take place over the course of this cycle. In other words, you have these ovaries, they develop these eggs. They develop in the ovaries, and around the eggs, the oocytes, you have follicles that develop, and these follicles change morphology as you go through the cycle. And we also have a cyclical nature in terms of the changes in the plasma hormone levels, and as we'll talk about in a moment throughout this lesson, that means changes in the gonadotropins and changes in the sex hormones, and the stages of the cycle are characterized by changes in these hormones. Okay? What makes this particularly complicated is that these two things are related. In other words, the changes to the follicles are dependent upon changes in hormones, and when the follicles change, they change the hormones level. So it's this circular process where follicles change the hormones, hormones change the follicles as they develop, and then die off, okay? So that is something to keep in mind, and that's why we're taking our time over this and going through it gradually, okay? The functions of the reproductive system, just to make sure that we're all starting on the same level. Basically, the function of the female reproductive system is to produce ova and nurture those and get them to the point where they will develop, and pregnancy will at least occasionally develop, and you deliver a newborn human. The female produces literally millions of ova before puberty, about 7 million at least. These are developing embryologically, as we'll see in a moment, as well as through childhood. Now these undergo a process called atresia, which basically means they shrink up and die. Down to a certain number, and that certain number is a small fraction of that million. So the vast majority of these oocytes will undergo atresia, and in fact, of the ones that start the cycle, as we'll see in a moment, most of those will undergo atresia as well. And so really, when you look at the number that are actually ovulated, it's a very small percentage of this millions. The process of atresia takes place because there are no gonadotropins around. You need LH and FSH in order for those follicles to develop, along with the oocytes, into something that can be ovulated and fertilized. And so during childhood, the gonadotropin levels are very low, and so these follicles tend to die off and shrink up. They don't ovulate, okay? Okay, so let's talk about some of the major hormones that are involved in this cycle. Of course, the most important one, I think most of us would agree, is estrogen. Estrogen is a steroid hormone. It is secreted from the granulosa cells. These are cells that are within this follicle that is surrounding the oocyte. But you should recognize that the thecal cells in the follicle also play a role in the secretion of estrogen. So what the thecal cells do is they supply androgen precursors to the granulosa cells, and then the granulosa cells secrete the estrogen. So we'll emphasize this more later in the lesson, but there's this exchange of precursors between the thecal cells and the granulosa cells and the thecal cells that takes place. And in particular, although the final step is in the granulosa cells, the production and secretion of the estrogen, the thecal cells are necessary for the process as well. We'll talk more about that. FSH stimulates the production and release of estrogen because it stimulates an aromatase, which converts testosterone to estrogen. We will see that later in the lesson. LH stimulates thecal cells to supply androgen precursors, so it also can play a role in increasing the production of estrogen just by supplying more androgen to the granulosa cells from the thecal cells, okay? As with most steroid hormones, the vast majority of this is bound to proteins. Only about 2% is free in the plasma, something that you may keep in mind. And amongst other things, estrogen produces the secondary sex characteristics in the female, and it is very necessary for ovulation. As we will see in a moment, estrogen will go up for a period of a couple days before ovulation takes place. It is necessary for it to go up reasonably high for a reasonably long period for that to happen. Progesterone is also a very important steroid hormone in the female. It is produced by granulosa cells, mostly those in the corpus luteum. As you will find out in a moment, there is a luteal phase of the cycle where granulosa cells transform themselves into the cells of a corpus luteum, and these are very good at secreting progesterone and some estrogen as well. LH stimulates the release of progesterone from the corpus luteum. Human chorionic gonadotropin also does this in pregnancy. We will talk about that much more in the pregnancy lesson, so you needn't worry about that right now. Again, the progesterone is mostly bound to plasma proteins, and it plays a role in stabilizing the endometrial layer in the menstrual cycle. So what you're going to find out is that this endometrial layer is built up during the cycle. Progesterone stabilizes it and keeps it stable for implantation. Should pregnancy take place, and if it does not take place, progesterone falls and the endometrial layer becomes destabilized and you bleed. It also stimulates the growth of the breasts. We have inhibin. I have a section in your notes boxed off that talks a little bit more about inhibin and activin. Not a lot is known about activin, and I'll explain to you what is known. Inhibin, more is known. It is involved in the cycle, but neither of those hormones is as well developed in the literature or in the textbooks as the steroid hormones, and so we'll emphasize the role of the steroid hormones more than anything else. Inhibin is a glycoprotein, not a steroid protein. FSH stimulates its release from granulosa cells in the female. It does play a role in the male, and we won't worry about that a lot in this lesson. You should bear that in mind. We'll talk about it later. And it is a protein, so it is not primarily bound in the plasma. It is mostly free, and it inhibits the release of FSH from the anterior pituitary during the cycle. So there will be, are actually long periods of this cycle where FSH is low and inhibin is playing a role in keeping it low. And we'll talk about that. So the female menstrual cycle. You see it here in all its glory, typically a 28-day cycle. During this cycle, oogenesis and folliculogenesis proceed cyclically, and as I explained earlier, these produce changes in hormones, which produce changes in oogenesis and folliculogenesis. So it is a cyclical connected behavior. The changes in the hormones are driven by changes in FSH and LH, your gonadotropins. These change estrogen and progesterone primarily in the female during the cycle, and so the cycle is characterized by the levels of these hormones, and we will go into that in enormous detail. The changes in these hormones also produce changes in the state of the uterus. And as we will find out, that is why you bleed. So 28-day cycle, we can break it up into 4 sort of general phases. The first 2 that we will talk about are the follicular phase, which leads to ovulation. So this is a phase where your follicles are developing and growing and preparing for the ovulation of the oocyte. Ovulation is a process by which the follicle literally breaks open and the oocyte is released through the wall of the ovary and into the uterus. That is followed by a luteal phase. The follicular cells become cells that form what's called a corpus luteum. The corpus luteum is nothing more than the follicle. After ovulation, there are morphological and biochemical changes that take place that cause this to be particularly good at secreting progesterone, which is going to be high during this phase. And then when progesterone falls, you enter the menses phase where the endometrial layer destabilizes and women bleed from the uterus, okay? The cycle is variable across the population in length and even within the individual, and the variation seems to have to do with the variation in the length of the follicular phase, which is something we'll spend a lot of time on. That seems to be the primary determinant of how long this cycle is going to be, or how short it's going to be. And the cycling begins at puberty, of course. Again, we have this menses phase. That's the bleeding caused by destruction of the endometrial layer, which is being built up during the luteal phase. We have a follicular phase where follicles, which contain your oocytes, are recruited for development. And then as that phase progresses, selection will take place until one dominant follicle is selected, and after a continual, after some progressive growth, and eventually the selected follicle dominates, and that's the one that ovulates during ovulation, which is again the rupture of the follicle and the release of the ovum into the fallopian tubes, and that release takes place not just through the wall of the follicle, but through the wall of the ovary as well. And then we enter our luteal phase, where the follicle regresses into a corpus luteum. That is, it's transformed into a corpus luteum, which produces progesterone and some estrogen, and that maintains the endometrial layer of the uterus in a nice big fluffy state where implantation can take place where should pregnancy develop. And then the phase enters menses again if pregnancy does not develop, and we go through the cycle over and over again.